Hello and welcome everyone, myself Vishal, and in today's video we are going to solve another interesting problem of Leetcode maze challenge. So the problem name is cousins in a binary tree, and in this problem we have to find whether two values given within a tree are cousins or not. So let's understand the problem statement first, and after that we will move towards our approach that how we can solve this problem. So given a binary tree, suppose here we have a binary tree, so we have to check whether given two values x and y are cousins or not. So here binary tree is given as 1 2 3 4 and its binary representation is like this. So value of x is 4 and value of y is 3. See, they are not at same level or not at same depth, so they are not cousin. Here note 1 2 3 null null 4 null 5. So binary representation of this array is basically this. Okay, and now we will check whether x equals to 5 or y equals to 4 are cousin or not. So x equals to 5 and y equals to 4 are at same level. Also we are checking whether they belong to same parent or not. So they doesn't belong to same parents, so that's why they are cousin. If they belong to the same parent, in that case they cannot be considered as cousins, because in that case they are siblings. So basically we have to check whether two values are cousins or not. So let's begin. Let's move towards our approach. So guys, our approach is very simple. Suppose we have this binary tree, and the problem statement says whether two nodes in this tree are cousins or not. Suppose we are taking node 2 and 3. So we have to check whether 2 and 3 are cousins or not. So firstly we will check the depth of these two nodes. So depth of these two nodes are basically 1. So depth is equal, but they belong to the same parent, so they are not cousins, they are siblings. So in that case our function should return false. Now check whether 4 and 6 are cousins or not. So 4. So depth of 4 is basically 2 and depth of 6 is basically 2, because here it is depth 1 and here it is depth 2. So they have same depth. We will now check the parents. So parent of 6 is basically 3 and parent of 4 is basically 2. So parents are not same, so they can be considered as cousin. So they are cousin, and in this case we will return true. So basically we are going to create a function which will return as the depth of a particular node as well as the parent of that particular node. We will return an array and the 0th index of array. Suppose our function is like get level, and the value is 4, suppose. So suppose if our function is like this, it should return its depth, which is 2, as well as its parent, which is also 2. So 0th index of this array will represent the depth and first index will represent the parent node. Okay, so our function will return like this, and in the main function in which we are checking whether they are cousin or not, we will firstly compare this depth. If depth are not same, then we will return basically false, and if depth is same, we will check whether parents are same or not. If parents are same, then they are not cousins, we will return false, and if parents are different, we will return true. So let's code and see whether this approach works or not. So guys, let's understand the solution that we have created, and let's look over the code. So firstly we have been given a function which is cousins, and we are getting the root of the tree node and the value of x and the value of y. So for getting the label and parents, I have firstly created a function get label, and this get label gets the root node, the value of x, means the value, the level, initial level, and the parent. So initially firstly we are passing x 0 root dot value. What we are passing? We are passing the root node, the value of x, the initial level is 0, means the depth of the tree initially is 0 basically, and value of the parent value of the root node. Okay, so why we are giving the value of root node? Because the value of root node is the value of the parent node. Okay, so initially if the root is equals to null, means if there is no root left, in that case we will basically we will return -1 and -1. I will come back to it that why I am returning -1. Suppose the root value is equal, okay, means the value of root is equal to x. In that case we will basically return the label and the parent of that root, okay, and we will also return the result. Means firstly we will create an array and then store the label and parent of the particular node and then return. Means in that case we will basically get the value of label and the value of parent node, okay. Otherwise if root dot value is not equal, in that case we will firstly traverse through the left part of the root, left subtree, or after that we will traverse through the right subtree. So the root is going to be presented the value is going to be present either in the left subtree or in the right subtree, because in this tree basically no nodes are repeats, so either it will be either present in left subtree or in right subtree. So in both of the cases one of the value will return -1 because if no value will be found, it is going to return -1. So we are firstly storing the result we are getting after this function calls, okay. So if the value of I0, I have told you that I0 is returning the label, so if value of I0 is -1, it means that in this particular traversal we are not getting the value of x anywhere. So we will basically return the results we are finding after traversing through right subtree of the tree, okay. Now after getting this we will have an array of both the elements, means firstly we are calling this for x and then we are calling this for y. So in level x we will get the value of the parent, and the depth of x. Also in level y we will get the value of parent and depth of y. So if their level are equal as well as their parents are not equal, we will return true, otherwise we will return false. So this was the basic approach, and now let's run this code and check whether it's working or not. So see, our solution is accepted for this test case, and now we are going to submit and see our solution is going to be better than all other solutions. So let's see. So yeah, our runtime is 0 millisecond and runtime beats 100% of Java submissions. So what will be the time complexity of this solution? The time complexity will be big of log n, because we are traversing throughout the tree and searching for an specific element. So for each traversal, for each round, we are moving towards left subtree and right subtree. So for each node we are dividing the subtrees into two equal parts. So as if you will go into mathematical calculations, it will come as big of log n. Otherwise, if you want the detailed explanation, please let me know in the comment section. Hope you understood this approach. If you like this video, please like, comment, share and subscribe. And if you are missing out something in this video, if you are unclear about anything in this video, because basically I am new in making videos related to coding, that's why it may be possible that I am not able to explain the things properly to you. So in that case, please let me know in the comment section so that I can improvise myself.